Okay, then now move on to the Maxwell equation, which is made of 4 equations and governs the electric and magnetic fields, as I explained in the previous slides. And the first equation is divergence D equal rho. Rho means the charge, and charge gives a divergence of D, which is I will go into this D again later. D equal epsilon 0 E plus polarization. So it's a kind of the electric field by applying electric field, so which is called electric displacement. So this equation corresponds to the figure 1.1. If you have a charge, it generates electric fields around the charge. Right? And then the second equation also similar. So divergence H equal 0. In this case, if you have a magnet here, you can put some magnet value here and generate a magnetic field. However, usually magnet cannot be separated into north and south one, so you cannot separate them. That's why usually the magnet equals 0. And then this equation also means a magnet makes a magnetic field. And the third equation is rotational E equal minus dB dt. So meaning, again, this one also B is magnetic displacement, which means mu 0 H plus M. So meaning that by applying a magnetic field, magnetic displacement is induced. So I'll come back to this later again too. But anyway, so the induced sort of magnetic displacement, so magnetic displacement change in time, right? Change in time, that gives the rotational electric field. And then the fourth equation, so also these third and the fourth equation are kind of pair. So rotational H equal I plus dt d of t. So again, this one is the electric displacement. So this equation means, so if you have a current, you could observe the rotational magnetic field, which corresponds to this one. So if you have a current, and you can obtain this rotational magnetic field. And the other one is, other term is the temporal change of the electric displacement gives a rotational magnetic field. And also this is paired with 3 and the equation 3. The temporal change of the magnetic displacement induces a rotational electric field, and this combination gives so acceleration of charge or rotation gives the electric and magnetic field, and sometimes it generates a light. We'll be coming back here too. And then we introduced the electric displacement and magnetic displacement, meaning, let me explain in more detail. So in vacuum, the B equal 0 H, and then D equal option 0 A, and then 0 is magnetic which is 4 pi times 10⁻7 Henry per meter. And epsilon 0, which is more familiar, and in vacuum it's about 10⁻12 or per meter. So what that means is if you have a light propagating like E field and E field and H field, and in the vacuum, there's some sort of the magnetic field and electric field proportional to the H and E induced in the vacuum, which corresponds to the B or D. And it's more clearer that if you have a object or material here, in this case, does B equal 0 H plus magnet, and then D equal 0 E plus P. So this, in the material, if you apply an electric field, for example, a plus and minus is induced, which corresponds to the polarization, right? So this is an electric displacement inside the material. Similarly, magnet is induced inside the material. So this one corresponds to the inside the material. And then this one is in the vacuum. So meaning that the electric displacement or magnetic displacement are caused by the sum of the field induced in vacuum plus materials.